This is a 3D printer. What it does is it makes things. It makes real three-dimensional objects using just code, essentially, or basically a 3D document. Think of it kind of like how your printer, your 2D printer that prints out paper, it pretty much prints from like a normal document, say like a Word document or a Pages document or a PDF. A 3D printer takes a 3D model or a three-dimensional model and prints out something real, typically using plastic, or at least for most of the consumer ones, there's plastic. Eventually, we'll start seeing metal and all types of things being made with a 3D printer. There is already some metal 3D printers out there, so you will start already seeing these things, but for the most people that have a personal 3D printer, they have one that actually prints out in plastic. What you see here is the MakerBot Replicator. This is one of the most popular companies, MakerBot is, for personal 3D printers. Now, there are also large-scale 3D printers that companies use and buy, but those often cost $500,000, where this thing costs only a couple $1,000s, which is a huge cost savings, and the quality of them are pretty close. Now, the $500,000 one is a lot better, but it's only slightly better. Now, a lot better makes, or slightly better makes a huge difference when it comes to making precise tools or objects. So companies that have them for a very good reason. Now, what it does is it layers plastic on top of other plastic. So it melts down some plastic and then layers that plastic. And it works just like how a regular printer does. So if you follow the mouse, it goes left and right, just like a regular printer, right? But only imagine if it went left and right and then up and down, or, well, more specifically, up. So that's what it does, is it layers plastic, it melts it down, and then it goes back and forth and then up. So it does it in a very, very thin layer of plastic, and that next layer of plastic molds with the previous layer, and then it keeps going until it actually makes an object, which in this case is a little bunny. So this is a little bit of a different process than what a CNC machine does. So you may have seen this. CNC machines and 3D printers, for that matter, have been around for a long time. But the CNC machine, what it does is it actually cuts things out, right? So it uses the 3D model as well, but it cuts it out of whatever, like if you put a block of wood down or something like that, it would cut it out of that. So that's subtractive manufacturing, where 3D printing is additive manufacturing. That's another term that they call it. So in this class, what we're going to be doing is talking about just the basics of how to build one of these 3D models. And the huge advantage to 3D printing is, number one, the unit cost. So each one that you produce is fairly inexpensive. Like if you see this right here, as far as the amount of plastic and stuff like that goes, not including the price of the printer, this thing right here might cost 40 cents, maybe 50 cents, maybe $1, versus buying it at the store, it might cost $20 or something like that, or $15. Those are US dollars, of course. And when it comes to doing stuff like that, that allows you to prototype all types of products for way cheaper. Because if you bought this at the store, it's usually done what's called injection molding, which means that they create a mold of this and then they spray plastic into it, and creating the actual mold and machines to do all that it can be a very expensive process. So 3D printers make it a lot less expensive to make your first prototypes, especially for entrepreneurs that want to launch their product, let's say maybe on a crowdfunding site like Kickstarter or Indiegogo. You would be able to actually use a 3D printer to prototype whatever that product's going to be, which is pretty cool. So 3D printers also can make things that don't exist in any other manufacturing capability. Like something like this would be very, very hard to manufacture with injection molding because of the actual properties of how it's done. But a 3D printer can do it. Not all 3D printers, but a 3D printer could do it because it's going layer by layer. And then it also can do some cool different designs like this, where traditional manufacturing, it might not come out as crisp or as solid or nice looking. There's all kinds of that you can check out on MakerBot's Thingiverse, so Thingiverse.com. This has all types of 3D printed objects that you can download and actually print on your own and make them at home if you own a 3D printer, or by using a 3D printing service. A big popular one is like a chessboard, and like as you see, these are very unique actual objects. So all types of things on Thingiverse show some really unique ones. And if we go to our popular ones here, we'll see just very cool stuff that people have been able to develop at home, right? These aren't necessarily professional designers building this stuff. They're just people like you and I that are just playing around with learning how to build 3D models and then putting it on Thingiverse to actually give to other people so they can download it and try it out themselves as well. So there's all really cool kind of things on there. There's one more service that I want to show you is if you go to shapeways.com. This is a service that will actually 3D print objects for you, and they will sell 3D printed objects for you. And this will do all types of materials as well. Where the MakerBot uses plastic, so MakerBot.com is where you would find the different 3D printers that are for sale. It uses plastic. Shapeways can use all types of materials, which is really, really cool. So if you wanted to design, a special ring for your significant other, you could do that here, or a necklace or something like that. Like this anchor right here, that's probably in gold. It's $163, so it's probably actually in gold. Or no, it's actually in raw silver, or you could try it in polished silver, and that's what would come out, and you'd be able to actually have that, and it would be an object that you designed and then was printed on Shapeways, or you could just buy one that somebody else designed and do that too. So this is a cool site to check out, or actually both of these sites, Shapeways as well as Thingiverse, are two sites that you check out to kind of get some inspiration as far as 3D printed items that you could actually build yourself. So let's actually close these out. And then there's also this website, 3Ders.com, .org, is a great website to do price comparison of 3D printers that you might consider purchasing. I would definitely do more research on any individual one of these, because this is kind of an exhaustive list. It doesn't mean that these 3D printers are of high quality, because the technology behind 3D printers, at least for the personal 3D printers, is still being developed. So it's not perfect, and it does not work like your inkjet printer at home that prints out documents. It works well. It probably works a lot more like the old printers that took forever to print, because actually printing stuff out does take a while. So like an object of this size probably would take about 8 hours to print. Maybe a little less, maybe a little more, but around 8 hours to actually make this using plastic, which is a long time, but considering that you don't have to do anything after you press print, it's not too bad. All right, so what's this class all about? This class is about learning how to actually design some of these products, some of these 3D models yourself. Now, it's not exactly a 3D design class, because we're not building this to be in a video game or to be in like some type of like movie or something like that. This is not for like graphics 3D. This is really for objects. So building real objects, so for 3D printers. We're going to be using OpenSCAD. OpenSCAD is another way to say it. This is an open source 3D modeler. There are other 3D modelers that are super expensive. This one is free because it's open source and it uses code. So this is one way to actually do it, is to actually code out how these models will look. So this right here is all code. All that is written in code, and it's created this object here that then could be printed out into a 3D object. And even on Thingiverse.com, you can also go there and see that OpenSCAD is also here. So if we open SCAD, if we search out OpenSCAD, you will also see all types of models that were written in OpenSCAD too, with the code and stuff like that. In some cases, they'll actually give you the code as well in their thing files. So .scad would be what you'd see, and then also it gives you the actual code there as well. And all this stuff is growing. It has a growing library and stuff like that. There's one more thing that you might want to check out is 123D Make. This is from Autodesk. Autodesk does all types of 3D modeling stuff. It's probably one of the leaders of building 3D model software and all types of architectural software too. So what 123D Make is a free software for all of the rest of us who want to just build our own app or our own objects and stuff like that using 3D printing technology, and also using cut it out of cardboard type of stuff. So you'd be even able to do some hobby type activities as well. And they have all types of different ways to use it. So we will eventually get into Autodesk 123D, but for now, what we're going to be focusing on is OpenSCAD and just the basics of it, because this is really just a basic introduction to it. If you really enjoy this introduction, please let us know so then we can continue to build more classes around this concept. All right, well, thank you so much, and we will see you in the next one.